All right. So, hi, hello.
No, sir.
All right. So, ihi na yung mga iihi. Kain na yung mga gustong kumain. So, we'll continue at exactly 4:58 since mahaba-haba pa to. Like less than 30 slides pa. Anyway, we'll try to finish this one right now. Hope we can finish them today. All right. So, it's already 4:58. So, let us continue now our discussion. So, are we clear so far on why do we have negative 2 volts in here? All right. So if ever that you have a clarifications, just let me know. So in here, since this one is ideal, so we only have 0 volts right here. So negative 2 plus 0 is equal to negative 2 volts. So let's now move on to example number 12. So in here, solution during positive half cycle. So ito, same na same lang sa examples natin kanina. So positive is connected to positive and then negative is connected to negative. So all throughout this will become a forward bias. Okay, and as a result, we have to consider everything. And again, so pipili lang kayo kung ano yung flow of current. Okay, so of course, the higher the voltage, that is the one that will dominate the entire flow of circuit. So in here we have a clockwise circuit or clockwise current rather, not circuit. Okay, so we have positive 5 and then negative 0.7 and then positive 2. So just add everything and then you will get 6.3 volts. Okay. All right, that's okay, Mr. Jim Lexus. All right, so are we clear so far regarding with this 6.3 volts? I think parang pangatlong example na natin to na 6.3 volts yung result. So I think there is no problem regarding with this one. And then during the negative half cycle, so of course, parang naulit. Hindi. Okay. So in here, this one now is non-ideal. So same scenario sa kung ano man yung discussion natin kanina dito or yung explanation. So at 0 volt, we have a reading of negative 2 volts. But since this one now is non-ideal, so we have to deduct the voltage at threshold of this diode. So negative 2 plus 0.7 is equal to negative 1.3. Okay. So nadagdagan lang ng voltage at threshold. Okay. So let's now move on to the fourth type of clipper. So in here we have shunt or parallel positive clipper. So when we say shunt, so it's equal with parallel. So don't get confused with this word shunt. So the word shunt is equal to the word parallel. So in here, the output is in parallel with the diode. Hence the circuit name parallel clipper can limit either positive or negative alternation of the input signal. Okay? So, ito, depende na to lagi sa polarity ng circuit mo, I mean ng diode mo. Okay? And then at the same time, of course, depende rin to lagi sa polarity ng kung positive half cycle ba or negative half cycle. So, they just differs when it comes to voltage output reading. Okay? Kasi yung reading natin is now on the this one itself. So, before, magdidikta pa tayo kung ano yung makiklip. Is it the positive side or is it the negative side? Okay, but in here, the reading is now on this part. Okay. So this one completely provides output if the diode is in reverse bias, and then there is no output if the diode is in a forward bias. So ito, kung ano talaga yung sinabi dito, yun na yun. Okay? So there is an output if we have a connection of reverse bias from our voltage input and then the diode itself. And then there is no output if we have a forward bias. So this one is the opposite of your series clipper. So before, kapag sa clipper natin, pwede nating piliin. Kapag forward bias, there is an output. If it's reverse bias, there is no output. But that one still depends on the bias voltage. So pwedeng meron pa rin kahit na reverse bias. But in here, we have a complete output if it's in reverse bias. And then there is no output if it's in a forward bias. So you will see later on why is it like that. So let's have this example number 13. All right, so we have here positive to positive and then negative to negative. Okay, as a result, we have here uh, a closed path. So the reason why all right. So in here, if you guys are going to take a look at this one, we have a forward bias connection. So just change that one into a line, okay, a closed path. And as a result, okay, so we have here this flow of current. Okay, forward bias nga kasi siya. So babalik lang siya dito sa V1. So if you want to have a reading of VO, you must have a resistance in here. So ito yung parang RL na tinatawag natin. Okay, ito yung voltage across RL or the voltage drop across RL. But as you guys can see, there is no component in here. So if you are going to read the voltage output reading, we have 0 volts reading in here. Kasi parang, yun, pabalik-balik lang siya. And then if you want to have a reading, so it must be at this point since nandito yung voltage drop natin or yung voltage reading across this R1. But since this one is just a line, so wala tayong reading ng VO. Okay? And vice versa. So, dito na rin yung example ng negative. So, ano ba to kanina? Okay, so kunin na lang natin yung susunod. And during the reverse bias, ba't nagloloko? Okay, so during the reverse bias, so negative to positive and then positive to negative. So this one is a reverse bias. So as a result, this will become an open circuit, right? So all of our reading will go directly to our probe, okay, which is the, let's see, ito yung positive probe natin, and then this is our negative probe. So dadali dito yung negative 5 volts, and then at the same time, lalabas siyang negative 5 volts pa rin. Okay, so that is why we have reading when it comes to a reverse bias connection, but there is no reading when it comes to a forward bias connection. So are we clear on why on reverse bias we have a reading of voltage output, but when it comes to forward bias or during positive half cycle, we have a 0 volts reading. Okay? So ito na lang magiging basis nyo when it comes to shunt or parallel positive clipper. Okay? As simple as that. Okay? Anyway, let's have another example wherein this one now is non-ideal. So during the positive half cycle, so we have forward bias. But then again, if you are going to replace this one, so this is a closed path, and at the same time, this one now is non-ideal. So nasa na yung positive. So this is the positive and then negative. So if you're going to read this one, whatever is your voltage, or your component right here, of course, will be your reading. So that is why VO is equal to your voltage threshold. So VO is equal to 0.7, which is this one itself. Okay, so that is why we have 0.7 right here. And na-include lang dito yung BB, pero wala pa naman tayong BB or yung bias voltage. So just neglect this one for now. Okay? So are we clear regarding with this 0.7 volts on a positive half cycle? All right. And during the negative half cycle, so the same. Okay, so magiging reverse bias to, and then our only reading will be this negative 5 volts. Okay. So we could say that when it comes to reverse bias, VO is equal to VI. Okay, but when it comes to forward bias, okay, so we could say that VO is equal to VB plus VB, whatever is your component that you can find, or the voltage sources that you can find in here. Okay. Anyway, so that's it without a bias. But what if there is a bias voltage with this shunt or parallel positive clipper? So when VI is less than VB, we have a reading of VO is equal to VI. And when VI is equal to VB, we have a reading of VO is equal to VB. Okay, so parang ito yung scenario na sinasabi natin kanina. But this one now is much more applicable with this one, since uh, parang heavily reliable itong formula na to. Like before, nakadepende lagi sa lahat. So in here, when VI is really less than your VB, then you can see that your VO is really equal to VI. And then when VI is greater than VB, then we could see that your VO is equal to your VB. Okay, though we still have to consider this scenarios wherein during the positive half cycle, and then if we have a positive bias, we have VB plus VB. And then if we have a negative bias, we have VB minus VB. So at the end of the day, it just, depends on the polarity of your bias voltage. So kapag positive, positive din yung bias voltage natin. If it's negative bias, then we have negative bias voltage. And then during the negative half cycle, VO is equal to VI. So you can use this one all throughout when it comes to shunt or parallel positive lever. Okay, so let's have an example. So in here, we have a bias voltage, but this one is still ideal. So positive is connected to positive, and then negative is connected to the negative. Okay, so our only reading will be this bias voltage, or you could say plus the ID, I mean the voltage threshold of the diode. But since this one is ideal, so it's just a closed path. Okay, so magiging closed circuit lang to, or closed path lang to, and then our only reading will be this VB. So that is why we have positive 2 volts in here. Okay, and then para hindi kayo malito, just base that one on the symbol of this one. So kung ano yung nasa taas, okay, that would be your symbol, or signage rather, not symbol. Okay, wherein we have here positive 2 volts. Okay, so yeah, and for the negative half cycle, so this will become a reverse bias. Okay, and then at the same time, so positive is connected to the negative, so reverse bias then. So all throughout, this one is an open circuit. So our only reading of VO will be this negative 5 volts. So lahat siya, or lahat ng voltage natin is dadaloy dito sa VO natin, coming from our VI. So are we clear? Are you guys able to follow? So reverse bias and reverse bias din siya. So sa VI man or mapa VB. So ang reading lang natin is this VI right here, wherein that is the only one that can flow on this VO path right here. Okay, so let's have another example. But this time, this one now is non-ideal. So same example pa rin. In here, we have positive to positive, okay, and then positive to negative. So at some point, hindi pala. Hindi at some point. Since all throughout, on this side, this one is reverse bias. Okay. And then all throughout, this one will become a forward bias. Okay, so if it's a forward bias, the only reading of our voltage will be this diode and then this bias voltage. Okay, so again, just consider the signage of this one, positive and then negative, positive, negative. So they have the same polarity. So 0.7 plus 2 will be equal to 2.7 volts. Okay, so again, supposedly this one is 0, but uh, we have a reading because of the bias voltage and then the silicon diode. So, okay. So are we clear with positive half cycle and why we've got here 2.7 volts? Okay, so if ever that you have questions, just let me know. And then during the negative half cycle, so this will become a reverse bias, and reverse bias din siya dito sa bias voltage natin. So all throughout, our only reading of VO will be this VI right here. So we have negative 5 volts. Okay. So again, if you're confused, just go back right here. Ito yung pinaka-clue nyo. Okay, provides output if it's in a reverse bias and then no output if it's forward bias. So your only reading if it's a forward bias will be the bias voltage and then the voltage threshold. So where are we now? Example 17, 16. Okay. So any question regarding with example number 16?
Wala naman po, sir.
Okay, so just let me know again kung meron kayong katanungan. Alright, so moving on to, oops, tapos na yan. So moving on to example number 17. So this one now is a negative bias. Okay, so we now have negative to negative and then positive to positive. But then again, we still have a higher voltage input. So all throughout, the one that will dictate is this one. Okay, so we have positive to positive, negative to negative. So this will become a forward bias all throughout. So again, supposedly if it's forward bias, so there is no output, right? But then again, since we have a bias voltage and then a voltage threshold, though in here we don't have a voltage threshold since this one is ideal. So our only reading will be this VB. So just get the symbol, I mean the signage itself. So the one that is above. So we have negative 2 volts. So are we clear so far? So nabago lang dito I think is the signage. Okay. So naging negative 2 lang to. So before this one is positive 2 volts, but this one now became negative 2 volts. And then for the negative half cycles, of course, we have negative to positive and then positive to negative. So we have a reverse bias, okay, all throughout. So ang mangyayari niyan, yes, at some point, we have a reading of negative 2 volts only. But of course, we have to consider the Vmax. Okay? So, pwede kasing dalawa yung maging sagot nyo. Initially, the reading is negative 2 kasi nga ito is negative, let's say, 0. So, meron tayong reading ng negative 2. And then at 1, mas malaki pa rin to. So, this one is still, will dominate in the flow of circuit. So, meron pa rin tayong reading ng negative 2. But once this one became negative 2 volts, so this will now become a reverse bias. So, if that happens, our only reading of voltage is now this voltage input. So, hanggang sa ma-reach niyo yung peak voltage natin, which is negative 5 volts. Okay? So, that is why we have here negative 5 volts. Okay, so one more thing, just like what I mentioned a while ago, again, during the negative half cycle, okay, so during the negative half cycle, you can heavily rely on this formula. So, hindi na to magbabago. So, depende na lang kapag yung, let's say, diode natin is nandito or yung resistor natin is nandito. So, hindi na yon shunt or parallel positive clipper. But if we have this kind of setup, then this one is for sure a shunt or a parallel positive clipper or negative clipper. Okay. So, eto, pwede nyong gamitin mismo itong formula na. Okay? So, that is by during the negative half cycle or when it comes to reverse bias, as always, VO is equal to VI. Okay? So, that is why we always have a negative 5 volts during the negative half cycle or during the reverse bias connection. Okay? So, are we clear with this example number 18? All right. So, last topic, not yet pala. So, this one is still part of the uh, number 4, okay, which is the shunt or parallel. But this one now is a negative clipper. So, kabaliktaran naman neto ngayon yon yung kanina. So, in here, we have a VO is equal to VI during the positive half cycle. And then during the negative half cycle, we have VO is equal to 0. Okay, so once you fully understood the positive clipper or the parallel positive clipper, so you will also understand this one. So just interchange the formula or interchange the things that will happen. Okay. All right. So here are the formulas that you can use. Okay, when it comes to during the positive half cycle, and then during the negative half cycle. So, kagaya ng sinabi ko kanina, same na same lang. Pagbaliktarin nyo lang. So, VO is equal to VI during the positive. And then during the negative, VB minus VB if it's a positive bias. And then negative VB minus VB during the negative bias. So, before, our VB is positive all throughout. But this time, we now have negative VB. Okay. And yung VB natin is, yun, naka-base pa rin of course to our, positive bias. So it's positive. Negative bias, that is why it's negative. Anyway, let's have an example with this one. So during the positive half cycle, so positive is connected to negative, and the negative is connected to the positive. So as a result, we have here a reverse bias. Okay, and if it's a reverse bias, all of our voltage input will go to our VO. So that is why VO is equal to your VI. So are we clear? Are you guys able to follow on why we have positive volts in here? Right. So during the negative half cycle, so we now have negative to negative and then positive to positive. So we have a forward bias. So if it's a forward bias, so we read our voltage output on this components only. So in here we have negative 2 volts and then negative 0.7. So just add them, you will get negative 2.7 volts. All right. So you can see that this one is a lot easier than the series clipper. So a parallel clipper is very straight forward. So any clarification? So were you guys able to follow this example number 19? All right, so we're almost done. So the last topic will be the clipper dual combination diode clipper. So in here, let me just make this one short since one just only talks about the connection, wherein we have V1, VB1, and then V2, VB2. So yeah, so we now have two diodes when it comes to combination, and then two bias voltage when it comes to this combination right here. But still, we only have one voltage input, and this one can flip both sides, so the positive side and then the negative side. So here are the formulas when it comes to positive half cycle, and then here are the formulas when it comes to a negative half cycle. But I think it would be easier if we're going to have an example right away. Okay, so in here, let me just get this one. So the idea of a shunt clipper will be carried out on this dual clipper. Okay, so during the positive half cycle, so we only have two possible scenarios. So positive half cycle, so we have this positive and then negative. So if you guys are going to take a look on this one, positive is connected to the positive, and then negative is connected to negative. So this will form a forward bias connection. Okay, and if it's a forward bias connection, so we read the voltage on this certain component. Okay, because at this point, positive is connected to negative. So let's just say that yeah, they will split into current. Okay, but this one is positive to negative and then negative to positive. So this one is in a reverse bias. Okay, and if it's in a reverse bias, so supposedly our reading of VO will be this VI right here, but that is not the case when it comes to a shunt, I mean a dual clipper. So when it comes to a reverse bias on the other diode, we have to read the voltage reading or the voltage output on this component right here. Okay, so this one is a silicon diode, so this one is 0.7. Oops. Ayaw. Anyway, this one is 0.7. And as you guys can see, we have positive 2 plus 0.7. We have a reading of 2.7 volts. So let me see if we have the same result. So yes, we have the same result as 2.7 volts. Okay, so we will only have a reading on the forward bias connection, which is this one. If it's reverse bias, just neglect that one. Okay, and then vice versa. If this one is negative, 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 and then positive. So on the positive cycle, VO is equal to 2.7. And then during the negative half cycle, VO is equal to, so let's see, we have here negative to negative and then positive to positive. So this will form a forward bias. Okay. And as a result, if it's in a forward bias, so we read the voltage output on this components right here. So we have negative 4 and then we have negative 0. Oops, 0.7. Okay. So as a result, negative 4 plus negative 0.7, we have negative 4.7. So in here we have positive to positive, uh, mali, negative to positive, positive to negative. So this one is a reverse bias. So the same with this one, positive to negative, negative to positive. So reverse bias. So when it comes to set one, when it comes to a dual clipper, we read the voltage output on a forward bias connection. Okay, so we have here negative 4.7. So for the positive half cycle, we have the reading on these two components. And then during the negative half cycle, we have the reading on this components. Okay, so 2 plus 0.7 is 2.7. And then 4 plus 0.7, so negative half cycle, so it's negative 4.7. So are we clear so far on how did we get those 2.7 volts and negative 4.7 volts? So as a result, we have here from 5 volts, only have a reading of 2.7 volts. And from 5 volts or negative 5 volts, only have a reading of negative 4.7 volts. So both sides were chipped, okay, or were clipped, right? So parang parang kung titignan niyo dito, wala nang reading mismo yung voltage input natin. Okay, ang naging basis na lang natin is this one. Okay, but just to take note, okay, that if we have here a 3 volts, magugulo na mismo yung concept ng dual clipper, because as you guys can see right here, this will never become a uh, reverse, a forward bias if we only have 3 volts right here. Why? Because as you guys can see right here, we have here, yeah, nagiging ano pa rin pala siya, nagiging forward bias. Though, wait a second, forward bias, at that point, it will become negative 3 point something. Yeah, so magiging iba na rin yung case. Kasi at this point, we have 2.3 and then meron tayong 4 dito. So, mag-iiba na yung result mismo ng voltage output natin. So, it's like negative 4 plus, kung 3 man to, 2.3. So, it's like 1 point something na only when it comes to a lesser voltage input. So, it's not completely the reading of these two components anymore. Well, anyway, so you will encounter more examples just by watching YouTube tutorials. So again, I have prepared here 5 links, though most of them are super basics. Talks about the fundamentals of a clipper. So if you want to have a hard examples, so you can find more. Maybe hindi ko lang na-include dito kasi I think lahat tong mga to, lahat sila parang introduction lang, which came from different YouTube channels. So yeah, make sure to visit. I think meron akong in-include dito na like, I think this one, it's Boylestad MCQ. So check this one out since ito is like 100 questions. So yeah, 100 questions to. Hindi naman. I think hanggang 25 lang pala. So I thought it's up to 100. But yeah, up to 25 only. So this will give you more ideas when it comes to clipper. Okay, do yung iba gumagamit na ng Zener diet. So sa next topic pa natin tong Zener diet na to. Okay, so clamper na to. Since combination na to ng clamper and a clipper. So clamper tayo next meeting. Okay? And Zener diode naman after that. And then the last one will be the LED or the light emitting lamp. And after that, of course, will be your final exam. Okay. So, any questions so far? So yeah, here is the reference or the where I've got most of the presentation or the slides itself from digital electronics. Yeah, mas mabilis ngayong finals. So we have to finish the topic next meeting, also the clamper. So meron pa tayong 3 meetings, like 3 meetings left. As long as we have 3 meetings left, we can finish those 4 remaining modules. So clumpers, Zener diet, and then the light emitting diet. So, kailan ba yung mga next meetings natin? So today is 24. Still have meeting this coming Tuesday 28, and then 1, 1, 2, and then 3. And then, so we only have exactly 3 meetings left. I think enough naman na yon. Sana matapos natin 1 module per meeting. So, yeah. And your final exam will be on October 8. Okay. So, dire-diretso yung meetings na. Unlike before, so, dapat pala nag-advance topic tayo, advanced meeting tayo ng midterms. Anyway, so yeah, sakto lang din naman yung oras natin. So if you guys don't have a question anymore, so you guys may now go. I
Bye, sir. Thank
really
you.
appreciate it that still parang kalahati pa rin yung pumunta since I think 20K dito if I'm not mistaken. So goodbye and thank you guys for coming.
Bye, sir.
Goodbye.
Thank you, sir. Bye, sir.
Goodbye.
Thank you, sir.
Thank you too.
Bye po, sir. Sir, yung sa may electronics lab exam ko po pala. Bukas na lang po, sir. Okay lang po.
Sige. I-message
Sige
mo
po,
na lang ulit
sir.
ako, okay?
Sige po, sir. Thank you, sir.
Sige. Thank you.